So in this function that we have defined now, we have two types of arguments. The first three arguments, which does not have the equal sign, these are the positional arguments. So these arguments need to be provided in this order. And the arguments with the equal sign, those are called keyword arguments. So that concept is going to be important for what I'm about to describe. So when calling a function, we might provide arguments as lists or dictionaries. So in the case of lists, we provide arguments with a certain order or a positional argument. So in this case, to demonstrate that, what we can do is to create a list of arguments. So let's call it args. And this is like the name that we usually use when defining arguments as lists. So the first argument would be spherical, and then I have the range 20 and the nugget 0.1. The range 2 is 40. And the contribution of the second structure is 0.2. So this is the exact same list of arguments that we used there. So let's see how we can now call a function by providing this object as the positional arguments in the order to this function. For that, we can use the star sign. So what this does, it provides these arguments in this order to this function. So if I run this should generate the same result as this call because I'm providing all the arguments. What we can also do is to slice this list to take everything but the last two items. So we are basically removing this two. So the second call here should be equivalent to this call. So if I run this now, we get the exact same result as this call, and the second one is the exact same result as this call. So by providing the list with the star sign, we are providing the arguments in this list to this function in that particular order. Another way of providing arguments to a function is providing them with dictionary. If we use a dictionary, then we can provide the arguments with arbitrary order because we are naming all the arguments. So to demonstrate that, we are going to use keyword arguments. And this is the name that you're going to see in most functions or places where keyword arguments are used. So this is a very common name to use for this type of argument. So let's create that dictionary. So now we're going to say nugget equals 0.1, and then range equals 40 or 20, and then range 2 equals 40, and then contribution 2 equals 0.2, and then shape equals spherical. So that is a dictionary. So as you can see, it doesn't matter the order. This order is not the same order of the arguments of the function, but because we have named the arguments, it doesn't necessarily need to match the order because we can match the names. So let's now call the variogram equation providing the keyword arguments. So for that, we use double star, and then we can call it. So in this case, all these arguments are passed to this function with the respective names, and the function will recognize that and just generate the result. So this format is very, very useful within workflows because we are usually looping over different variables or different domains. And if we assign or store the information for each variable on a dictionary, we can easily make a loop and call that function within the loop with the parameters that were defined for each variable. So to demonstrate that, we are going to create a variograms dictionary, and this variogram dictionary will contain the variogram parameters that we want to assign to certain variables or certain domains. So in this case, Potassic will have a specific variogram, and then Cericitic will have a specific set of parameters. So let's change a little bit. Potassic will remain the same, but then Cericitic, we are going to have a different nugget and perhaps different ranges. And let's say even different shape. So now this variograms dictionary holds the parameters for each one of the domains. And now we can call this function in a loop using that dictionary. So we can say for alt, which is going to be the alteration name, and the keyword arguments in variograms.items. So we already saw that when we use items, we can have access to the keys, which is going to be Potassic and Cericitic, and the values, which in this case is the keyword argument of that domain. So let's print the alteration name, and let's also call our variogram function. So for instance, we can do alt and add column here and F. There you go. So if I run this function now, what is happening is that we are looping over each one of the alterations and the respective keyword arguments, and we are calling this function with the arguments that were specified for each one of these domains. So if I look at the result, we see that for Potassic, we are using the Potassic parameters, and for the Cericitic, we are using the Cericitic parameters. So this is very useful within workflows, because this is exactly the same way that we define and store parameters for specific variables or specific domains.